In the 1950s, there was a surge of supersonic technology in the field of aviation. Both fighter jets and bombers were pursuing supersonic flight, and it seemed that speed was the key to victory. This trend also influenced the civil aviation sector, with people beginning to design supersonic passenger planes. In order to explore related technologies, Britain specifically designed and built the HP.115 experimental aircraft. At that time, people's understanding of the structural design required for supersonic flight was still insufficient. This can be seen from the design of fighter jets at that time. In order to achieve high-speed flight performance, the wings of supersonic fighter jets began to evolve into small delta wings. These wings were unable to generate enough lift at low speeds. In other words, the aircraft could not balance high-speed and low-speed flight performance. For commercial aircraft, low-speed flight performance is a must-consider issue. Passenger planes cannot pursue high speed like fighter jets. The HP.115 experimental aircraft was hoping to find a technological balance point. In the 1950s, the British Royal Aircraft Company discovered an interesting phenomenon, that is, the delta wings would generate vortices on the wings at large angles of attack, which would accelerate the airflow on the wings, thereby increasing the lift of the delta wings. Based on this technological discovery, Britain promoted the development of the experimental aircraft in the early 1960s. Originally, they only wanted to design an unpowered glider, but later thought that adding a tow aircraft for cost-effectiveness would be better, so the HP.115 was developed. The structure and design of the HP.115 is unique, mainly due to its wing structure requirements. The aircraft adopts a long delta wing design, with the wings extending almost from behind the cockpit to the tail, with a leading edge sweep angle of 75 degrees and a very small aspect ratio. The advantage of this design is that it extends the flow field for vortex lift, producing the necessary lift. In order to generate the required lift, the aircraft must constantly lift the nose during low-speed flight to produce enough vortex lift. In order to maintain a sufficient angle of attack during takeoff and landing, the aircraft has long legs. Its fixed tricycle landing gear looks quite long. With the fuselage noticeably upturned, in order to provide the flight crew with sufficient visibility, the nose of the HP.115 is noticeably downturned, allowing for a clear view of the ground during takeoff and landing. This design was also reflected in the Concorde supersonic passenger plane, except that the designers made the Concorde's nose a movable structure. The nose was lowered during takeoff and landing to ensure a smooth transition during high-speed flight. The engine compartment of the aircraft is located at the rear of the fuselage, using a high front and low rear mounting method, making the HP.115 a tail-mounted jet with dorsal air intake. The engine is a Bristol Siddeley Viper BSV.9 turbojet engine with a thrust of 8.5 knots. The vertical tail is mounted above the engine compartment, and there is a streamlined fairing on the vertical tail, inside which photography equipment is installed to record images during flight. Sometimes, a smoke generator is also installed on the aircraft to more vividly show the airflow movement. The HP.115 made its first flight in August 1961, demonstrating effective low-speed control capabilities during the test flight. Pilots were able to control the aircraft at a speed of 111 km per hour, and its related technological achievements were applied to the Concorde supersonic passenger plane. The HP.115 experimental aircraft had an empty weight of 1,669 kg, a maximum takeoff weight of 2,291 kg, a length of 15.34 meters, a height of 3.89 meters, a wingspan of 6.25 meters, a wing area of 40.1 square meters, a crew of 1 person, a maximum flight speed of 399 km per hour, and a range of 40 minutes.